What if I told you we have been building AI knowledge bases the wrong way this entire time? More data does not always mean better AI, and now research just proved it. For years, the AI world believed one simple idea: if we want large language models to be smarter and more accurate, just give more data. So we did exactly that. We built massive knowledge bases, documents, tables, images, videos, all dumped into one giant unified corpus. Sounds logical, right? Turns out it's actually holding AI back. Here's the problem: when everything lives in one huge pool, the AI has to search everything for every question. A simple factual query, a complex reasoning task, a visual question. They all go through the same data pipeline, and that's a big mistake because not all questions need the same type of knowledge. A new research framework called UniversalRAG exposes this flaw. The research shows something surprising. Just adding more data does not improve answers. In many cases, it actually makes them worse. Why? Because the AI is not failing due to lack of knowledge, it's failing due to how that knowledge is accessed. Real world users ask very different kinds of questions. Some need precise facts, some need structured data, some need reasoning across sources. Treating all data as equal and throwing into one giant search space creates noise, confusion, and weaker answers. This research introduces a smarter way to connect AI to knowledge, one that adapts how data is retrieved based on what the user is asking. And in this video, I will break down 4 surprising takeaways from Universal RAG that completely change how we should build AI knowledge system. Imagine giving an AI every piece of knowledge in the world and it still misses the best answer just because it's in the wrong format. Sounds crazy, right? Welcome to the modality gap. Most modern AI systems uses a simple idea: put all your data in one place, text, images, videos, tables, one giant knowledge bucket. Then when a user asks a question, the AI searches that bucket and pulls the most relevant result. At least that's what we think it's doing. Here's what actually happens. Ask a text based question and the AI almost always returns text documents. Even if there's a perfect image or a short video that explains the answer far better. Not because the image isn't useful, but because the AI literally struggles to see it. Researchers call this the modality gap. When we force all data types into one unified embedding space, they don't mix by meaning, they cluster by format. Text sticks with text, images group with images, videos stay in their own corner. The researcher visualized this and it looks like isolated islands: a text island, an image island, a video island, and almost no bridges between them. So when you ask a text question, that query is mathematically closer to other text. Even if an image holds the perfect answer, it's too far away in embedding space. The AI never even considers it. This is the real problem. The AI isn't choosing the best knowledge, it's choosing the most convenient format. It's logged into the lane it started in. So instead of the best possible answer, you get a suboptimal one that just happens to be text. Think of it like all you can eat buffet. But once you grab a plate, you are only allowed to eat from one section. Desserts, off limits, fresh dishes ignored. The food is there, the system just can't reach it. And this is only the first reason why unified knowledge bases fail. So, if one giant knowledge base does not work, what does? The answer is not more data. It's smarter way to choose which data to search. Universal RAG flips the old idea on its head. Instead of asking, how do we search everything at once? It asks a better question: what kind of knowledge does this question actually need? And that one change makes all the difference. Universal RAG introduces something called modality aware routing. Think of it like a smart router for knowledge. Before searching anything, the system first looks at the user's question and predict: do we need a text, an image, a video, or a combination of them? And here's how it works. Step 1: a routing module analyzes the query and decides where the answer should live. Step 2: the system searches only that specific knowledge base, not the entire mixed media universe. No brute force, no unnecessary noise, just targeted retrieval. And this works because real user questions are diverse. Some questions need simple text facts, others need visual understanding. What's powerful here is this isn't just intuition, the researchers prove it mathematically. Even if your AI finds the right data, it can still give the wrong answer. Why? Because sometimes it gets too much information or not enough. Most RAG systems make one quiet assumption: all data should be chunked the same way. Same chunk size, same retrieval strategy, same context window. And that's a huge mistake. The research points out something subtle but critical. If chunks are too small, you lose context. If chunks are too large, you're mixed unrelated information. Either way, a model struggles. It's not just what you retrieve, it's how much you retrieve. Take a basic question. What is the capital of France? You don't need a 10-page document, you need one clean sentence. Now compare that to a deeper question, something analytical or explanatory. That does need broader context, maybe the entire document. Same modality, very different retrieval needs. This becomes even clearer with video. If I ask what goal did Messi score in this match, I need a few seconds of footage. But if I ask how do I replace a bike wheel, a short clip won't help. I need a full tutorial. Same data type, completely different granularity. Universal RAG solves this by organizing knowledge at multiple granularity levels: paragraphs, full documents, tables, images, short clips, entire videos. Then the router makes another smart decision, not just where to search but how much to retrieve. This ensures the AI gets enough context to reason correctly without drowning in irrelevant information. The result: cleaner inputs, stronger reasoning, better answers. So, the real lesson here is simple. Good retrieval isn't about maximizing data, it's about matching context to the question. Universal RAG does not just fix what we retrieve, it fixes how much we retrieve. Here's the most surprising part of this entire research. The smartest part of the system does not even need training. You would assume that the routing module, the brain deciding where to search, must be heavily trained on labeled data, custom datasets, fine tuning, weeks of effort. But Universal RAG shows this assumption is wrong. The researchers tested two approaches: a training based router, custom trained on labeled queries, a training free router, no datasets, no fine tuning. Just a powerful front-end model like GPT or Gemini prompted to act as a router with a few clear instructions and examples. And here's the insight. Modern LLMs are already excellent at classification and reasoning. So instead of training a new model, you can simply ask the LLM, what type of knowledge does this question need? Text, image, video, multiple modalities. And it turns out that's often enough. The results were unexpected. Yes, the trained router performed best on familiar in domain tasks, but the training free router, it was more robust. It generalized better to new question types, new domains, and new knowledge sources it had never seen before. And this is a huge for real system because production data always changes. New content, new modalities, new user behavior. Systems that overfit to yesterday's data break tomorrow. So the paper proposes a hybrid strategy. Use the trained router when the system is confident and the task is familiar, but when confidence drops or the query looks unfamiliar, fall back to the training free router. High accuracy and strong generalization. Let's create a system that is accurate, flexible, resilient to change, and most importantly, practical to deploy. Universal RAG's final lesson is powerful. You don't always need more training, sometimes you just need better orchestration. For years, we believed smarter AI meant more data, but this research shows that belief was incomplete. The future of knowledgeable AI isn't about building the largest database, it's about building the smartest way to access it. Universal RAG makes a clear shift in thinking from hoarding information to understanding how and when to use it. Think of it this way: the best AI is not the one with the biggest library, it's the one with the smartest librarian. A librarian who knows which book to pick, which format matters, and even which chapter size fits the question. That's exactly what Universal RAG enables. When AI accesses knowledge intelligently, it becomes more accurate, more efficient, and genuinely helpful. No wasted context, no missed answer, no guessing in the dark. This shift opens the door to an entirely new generation of AI systems, ones that adapt, scale, and reason better as human knowledge keeps growing. And it leaves us with a powerful question. As we connect AI to bigger and more diverse knowledge sources, what other obvious assumptions are quietly limiting what AI could become? If this video changed how you think AI, hit like, subscribe for deep practical insights, and let's keep questioning the assumption behind intelligent systems.